So in this lesson, we're mostly just going to look at the second objective. So we'll do a brief review of solving proportions, then we're going to talk about using proportions to make inferences about a population. And inference is just kind of an educated guess. It's kind of like when you make a hypothesis in science, and inference is kind of similar to that. We're going to look at the information we have in our sample, and we're going to make a prediction, would be another word for an inference. We're going to make a prediction about the population. Okay, so just remember when you solve proportions, we've done so much of this and we've done it recently, you are cross multiplying. So this would be 5x equals 30, dividing both sides by 5, we get x equals 6. You guys all remember how to do proportions? Megan?
When you on the problem today, you said 10 divided by what equals 5, and then we could do like 2, and then something divided by 2 equals 3.
Yeah, you can do that by 2. That's another way. Okay. Do we need to go over any more problems, or are you guys okay with solving proportions? We're good. Okay. Okay, so here we are, objective 2 already. Use proportions to make inferences. You could also write in parentheses predictions. A shipment contains 3,500 cell phones. In a random sample of 50 phones, 3 are defective. How many phones in the entire shipment are likely to be defective? So we're just going to set up a proportion where we have how many are defective in the sample over the size of the sample, and that's going to equal how many are defective in the shipment over the size of the shipment. So it tells us that in a random sample of 50 phones, 3 are defective. So 3 out of 50 phones are defective. Now we want to know how many phones in the entire shipment are likely to be defective. Well, defective is on top, total is on the bottom, so that's what we don't know, is X. We don't know how many phones are defective. We know how many phones are in the shipment. The shipment has 3,500 cell phones, so now we just need to solve that proportion. So cross multiplying, we get 50x equals, let's see, 3 times 5 is 15, 3 times 3 minus 1 is 10. 10,500, sorry, I forgot my x there. 50x equals 10,500. Dividing both sides by 50, we get x equals 50. We're going to that twice. We have 5 left over. We're going once, 0. So we can predict that 210 phones would be defective out of that shipment. Okay, look at the second problem. What if 5 phones in the sample had been defective? Then how many phones in the entire shipment are likely to be defective? How could I set up a proportion if 5 phones had been defective instead of 3 phones? Megan?
Why does 50 equals x over 3?
Good. And how would that change my answer then? What would I end up with? I'd get 50x equals what, Megan? You can do it.
Wait.
3,500 times 5.
17,500.
Good. And then dividing that by 50. What do we get? We get 350. Yeah. 350. Okay, any questions about what she did?
I did it normal.
What do you mean you did it
I didn't
normal?
use a proportion.
Yeah, I didn't. That's why I was
I did it in my head.
What'd you do?
I took 3 and I figured out how many times 50 goes into 500, which is 10. And then I did 30.
Oh, okay, so you
I
did,
did 3
instead of
times
using a
10,
proportion.
And then 30, and then 30
I know what
divided
Kinda
by,
like-
and then 30 times 7.
Kind of like finding a scale
5
factor.
times 10 equals 50, and then you would do 3 500
Yeah,
divided by 10.
that's fine. You guys can absolutely do it that way. That's fine. Okay, let's take a look at one more set of examples. This is all we're going to do on here. Try this. I'm going to pause the video for a minute. Record this. Okay, so the answer to number 1, most people have this correct. You should have gotten 3 over 20 equals x over 200 and found that 30 lollipops were unwrapped. And then similar proportion for the second one, and you should have found that 40 lollipops were unwrapped. Okay, great job. You guys see why you didn't really need to spend a whole class on this lesson, because you guys already know what you're doing. Okay, now I'm going to open up the next lesson, so get out this set of notes.
We have to do
Okay, so we are going to be talking about making inferences again, but not always just using proportions. We're going to talk about how we make inferences from a random sample. This is really an easy objective. And then number 2, we're going to approach this a little differently. We're going to use multiple random samples. So we'll be using proportions, but within the context of having more than one sample. Megan? Yeah, I know. Don't worry about what unit it says. It's still the right things. I'm changing around the numbering system on my notes a little bit, and some of the copies were left over, and so they may look a little different. Okay, so here's objective 1. Here's our scenario. A restaurant manager selected a random sample of 20 customers and recorded the amount they spent on their meal. Based on the sample, which is the best estimate of the average or mean amount that customers spend on a meal at the restaurant? So remember when we talked about getting a random sample, we said instead of asking every single person in the population, we're just going to ask a sample, and we're going to let that sample make our prediction for us. So we don't have to do anything special here. All we have to do is find the mean number based on the numbers we have here, and that is our prediction for the population. So there's not really anything tricky to do here. We are using the sample to make our prediction. So take a second to figure this out. You do not need to write down all of your work because you have to add up all those numbers and divide by how many there are. Don't do this in your head. This is definitely one where using a calculator is the wisest move. Once you figure out the mean, you may go on to the next slide, which asks this in a slightly different manner. So you can think about that. I'm going to pause the video. Okay, so just hold tight till we go over it. All right, when we add all these up, and then we divide by, let's see, there are 1, 2, 3, 4, 5 across and 4 down, so there's 20. So you should have added them all up, divided by 20. The answer that you get is $16. So we would predict that that's how much the average customer spends on a meal at the restaurant. Okay, the next one says using the same random sample, and these are the same numbers, I just give you another table to look at. Draw an inference about the percent of customers at the restaurant who spend more than $20. And I saw a lot of you had this right already. Here's how I would approach this. I would figure out, well, how many customers spend more than $20? So I would circle them. There's 1, 2, 3, 4. Did I get them all? Okay, so there's 4 who spent more than $20 out of a sample of 20. So 4 out of 20 equals what percent? So X over 100. Nathan? 20%. X is 20%. Okay, the next part can be a little confusing until you kind of master the steps. And that's why I gave you 3 steps. We're making a prediction for each sample, comparing variation, and then making an inference. Let's look at our situation. There are 360 students at a middle school. Sonia, Jane, and Danny each survey a random sample of 25 students about whom they plan to vote for in the election for student council president. Their results are shown in the table. Use the samples to predict the number of votes Carlos will receive. Okay. So let's first look at Sonia's sample. So here's Sonia's sample. Sonia says, we're concerned with Carlos here. Sonia says that Carlos is going to get 12 votes. So her sample says that out of the 25 votes that are there, and if we add these three numbers up, we do get 25, and it also tells us that there are 25 in our sample. So her sample says that 12 out of 25 students are going to vote for Carlos. Now, we also know that there are 360 students total at the middle school, so we can use that in the other side of our proportion. So out of those 360 students, how many will vote for Carlos? Okay, when we solve that proportion, we get, let me see if I did the right one. Yep, so we get x is equal to, I'm going to use a wavy equals because it's about equal to 173 students who would vote for Carlos. Now we're going to move on and we're going to look at Jane's sample. And Jane's sample said that 13 students will vote for Carlos. Can I have a volunteer to set up the proportion for Jane's sample? Bryant, go ahead.
13 over 25 equals x over 360.
Good. We're still using the same thing on the right side because we still have that sample of 360. Did you solve it by any chance?
I know. Oh, yes.
First person to get an answer for this, raise your hand. Megan?
I got about 180. 180.
Good. About 187. Okay, and then the last one is Danny's sample. Volunteer to set up Danny's proportion. Phyllis?
15 over 25, and then x over 260.
Good. And did you get an answer for that yet?
216.
About 216. Good. X is about 216. So what we do, we're making a prediction based on each sample. We did that. That was step one. Now we're going to compare variation in each sample. All you're doing here is basically talking about the range. So you would say something like, the greatest prediction is 216, the smallest prediction is 173. So the predictions vary by 43 votes. You're just basically talking about the range. So the range is 43 would be the shortest way to say that. Because it's important to know if our samples vary by a lot, then maybe the people didn't do a good job choosing their samples. We would be alarmed if there was a really huge variation. This isn't too bad considering that there's 360 students. If there were only 50 students and you had a range of 43, that would be really alarming. So you don't want it to be too close to your total. Then it asks us to make an inference. When we make an inference, generally we just use the median number. So out of the three predictions that we just made, I'm going to take the prediction that's in the middle, which is this one, and I'm going to use that to predict how many votes. So I'm going to say my best prediction is that he would get 187 votes. Now you could also find the average or the mean of these three numbers, and you could use that. If you did that, you would get 192 votes. So it's possible to do it that way. The way your textbook presents this is to just use the median. Okay, any questions about this? Okay, your assignment is different than, I don't know if it appears on your notes or not. I'm going to give you a worksheet to do for homework, and just one. You don't have to do the homework from both of these sections. But numbers 4 and 5 ask you to do what we just did up here, so make sure you refer back to the notes if you need to.
Questions around